See, resistors in parallel or capacitors in series. So these two are a general problem which cause so many troubles. The first thing is resistors in series or resistors in parallel. How do you find the effective resistance? 1 by R effective is equal to 1 by R1 plus 1 by R2. Usually R1 R2 are given like this. So R1 is usually R1 plus or minus delta R1, where delta R1 is the error. R2 as plus or minus delta R2, where delta R2 is the error. When you find the resistance R, then R must have the error component delta R. So that is the objective. So usually one approach is like this. 1 by R is equal to 1 by R1 plus 1 by R2. So 1 by R plus or minus delta R, the error in R, is equal to 1 by R1 plus delta R1. So let me write that. R1 plus or minus delta R1 and plus 1 by R2 plus or minus delta R2. So in errors they always get added. So here when you take the reciprocal, R1 plus R plus or minus delta R whole power minus 1 equal to R1 plus or minus delta R1 whole power minus 1 plus 1 by here also R2 plus or minus delta R2 whole power minus 1. Using this relation, okay, so let's come back to that later then. When you take R out, it is R power minus 1 because power minus 1. 1 plus or minus delta R by R whole power minus 1. R1 if you take out, it is 1 plus or minus delta R1 by R1 plus R2 if you take out, it is 1 plus or minus delta R2 by R2 whole power minus 1. In general, when it comes to error, the error dr by R is a small value. The further only, suppose if it is 1 plus x whole power n, with 1 plus nx itself we will stop. The other terms will drop. Similarly here, R power minus 1 is 1 by R into 1 plus or minus delta R by R whole power n is 1 plus nx, because n is minus. When you subtract, multiply the minus here, 1 plus or minus 1 into delta R by R. When you multiply minus here, it is minus R plus delta R by R equal to 1 by R1 into whole power minus 1, here I missed it, 1 minus R plus delta R1 by R1 plus 1 by R2 into 1 minus R plus delta R2 by R2. Then when you multiply everything inside, so 1 by R minus R plus delta R by R square plus 1 by R1, sorry, not plus, it is equal to 1 by R1 minus R plus delta R1 by R1 square plus 1 by R2 minus R plus delta R2 by R2 square. So 1 by R is equal to 1 by R1 plus 1 by R2. So this can be grouped, 1 by R plus or minus delta R by R square equal to 1 by R1 plus 1 by R2 into minus R plus here also it is minus R plus 1 delta R1 by R1 square plus delta R2 by R2 square. So here 1 by R is equal to 1 by R1 plus R2. So delta R by R square is equal to delta R1 by R1 square plus delta R2 by R2 square. Then delta R should be found using delta R1 by R1 square plus delta R2 by R2 square into R square. So this is one approach. The other approach we can take is, because based on this I'm going to solve a problem after this. So both the approaches, how the answers differ, you just see for yourself, and based on the question you are supposed to choose your solution. Suppose instead of taking this approach here, we know that 1 by r is equal to 1 by r1 plus 1 by r2 means if you take LCM r1 r2, here r1 plus r2 will come, and here r is equal to r1 r2 by r1 plus r2. Then now when you take logarithm, log r is equal to log of, this is the approach which I have already discussed with you, r1 r2 by r1 plus r2. r1 plus r2 is a single term. Log of a by b is log a minus log a minus log b. So log of r1 r2 minus log of r1 plus r2. But this errors, they get added, so always, so instead of minus I'm just using the plus symbol. Log r is this. Now here one more step, so log of r is equal to log r1 plus log r2 plus log of r1 plus r2. When you take when you differentiate on both sides, generally dr by r is equal to dr1 by r1 plus dr2 by r2 plus d of r1 plus r2 whole divided by r1 plus r2. So this dr is nothing but delta r by r equal to delta r1 by r1 plus delta r2 by r2 plus, when you multiply delta inside, dr1 plus dr2, which is delta r1 plus delta r2 by r1 plus r2. So now based on this, what you get for delta r is equal to delta r1 by r1 plus delta r2 by r2 plus delta r1 plus delta r2 by r1 plus r2 into r. This is what the thing is. So based on two different approaches, you see we have got two different answers. So delta r in one way, it is dr1 by r1 square plus dr2 by r2 square into r square, and here dr1 by r1 plus dr2 by r2 plus dr1 plus dr2 by r1 plus r2. These are two approaches that is found ubiquitously in many textbooks. So many famous textbooks, one standard textbook set use this approach, the other one use this approach. I'm going to give you an example problem, so the answers you see for yourself. Suppose r1 is equal to 10 plus or minus 10.0 plus or minus 0.1 and r2 equal to 5.0 plus or minus 0.2. What is the resistor, effective resistance in parallel? So effective resistance in parallel, when you find out, let us use both the approaches here, and using this, first we have to find what is r. We know that r is equal to 1 by r is equal to r1 plus r2, r1 r2 by r1 plus r2. r1 is 10 into 5 divided by 10 plus 5, which is 50 by 15. The value is 3.333 and so on it goes. But look at these values. This has got 3 significant digits. This has got 2 significant digits. Your answer should contain only a maximum of 2 significant digits. The least of one you should choose. So in 3.333, you have to choose only 3.3. So the r value equal to 3.3. But what is delta r? So according to the first approach, delta r is equal to delta r1 by r1 square. Delta r1 is 0.1 by r1 square is 10 square plus delta r2 is 0.2 by r2 square is 25 into here r square. R square is nothing but it is like 50 by 15. So this can be 10 5s or 3. So you can write 10 by 3 whole square. That is even a sensible value. Instead of 3.3, you can choose that. So using this methodology, it is 0.1 by 100 plus 0.2 by 25 into 100 by 9. I'm just going to use my calculator here. So here 0.1 divided by 100 is actually, so actually the this is 0.001 plus here 0.2 divided by 25 is actually 0.008 into 100 by 9. So what value are we getting? 0.009 into 100 by 9, which is here what, 0.1. it is what we are getting. So based on this methodology, our R value is equal to 3.3 plus or minus 0.1, that is coming. So here use the second methodology where the R value follows this rule. So this rule, so here this rule, according to this rule, here delta R is equal to delta R1 by R1, which is 0.1 by 10 plus 0.2 by 5 plus 0.1 plus 0.2 divided by R1 plus R2, 10 plus 5 whole multiplied by R. R is nothing but 10 by 3. So this is 0.01 plus the value of this is 0.2 divided by 5. Just I am ensuring that it's correct. 0.04 plus 0.3 divided by 15 whole multiplied by 10 by 3. So 0.3 by 15, 0.3 divided by 15 is equal to 0.02. So 0.01 plus 0.04 plus 0.02 whole multiplied by 10 by 3. Suppose if you look at here, this whole thing, what are we getting? 0.07 into 10 by 3, which is nothing but 0.7 by 3, which is nothing but 0.7 divided by 3 is 0.233 and so on. So if you cut it to only one significant digit, it is 0.2. According to this, the answer of the resistance is 3.3 plus or minus 0.2. So I would say that this is the as far as what I know, this is the proper approach. This is the proper approach to find the error. But this one is another approach, but this is more of an approximated thing. While this is close to very actual value, this is an approximated value. But based on who takes the question and how it is how the answer is expected, you're supposed to do it. But I would say that prefer the first method, which is very close to the real answer. Choose the second method only when you are in a hurry or it is expected of you. So, but I'm not sure like which one to suggest, but I am only giving you both the things that are discussed in any places. But when it comes to finding the value of the percentage error, this will give you an edge. When you look at this value here, suppose when you look at this value here, it is very easy to find the percentage. Suppose what is a percentage error? So we know that when it is there, you bring the R here. So this R, you bring it to the left hand side, delta R by R. This is fractional error. So fractional error in resistance is equal to delta R1 by R1, which we have found out to be 0.01 plus 0.04, this one plus 0.02. When you add all this, delta R by R is equal to 0.07, which means that the percentage error in resistance is equal to fractional error into 100. So I'll use that. Delta R by R into 100, which is 0.07 into 100, which is 7%. In one shot you can do it. But if you use this value, you will also get the kind of value which is approximately the same, but this is the one when it comes to percentage errors. You can try this, but let us all, I'm here only giving the two approaches, but if you ask me, I will always go for the first approach. But in the first approach, delta r by r value here is, if you look at delta r by r, so delta r by r is, delta r by r square is delta r1 by r1 square plus delta r2 by r2 square. So here this square, only one r you take it to the other side, it is like that, delta r1 by r1 square, which we have already found out, 0 0.01, 0 0.008, which is 0 0.009, so which is 0 0.009 into r is 10 by 3. 10 by 3 means it is 0 0.09 by 3, which is 0 0.03. So percentage error is into 100. So 0 0.03 into 100 according to this is 3%. So if you ask me like what to choose, I don't know, because in both the standard textbooks I don't see any outright error in both approaches, but which approach to choose, and you have to decide.